Hey everyone, how's it going? In this video, I'm going to continue talking about STL algorithms. This one, I'm going to just talk about one STL algorithm, which is called accumulate. I will be using accumulate to kind of give you what I have done to create my own mean functions. So if I want to get the average of a vector or something, I'll show you how I typically go about creating that mean function and how I go about using it. But anyways, let's start. So I've pre-written my main here. So here I have a vector of doubles where I'm going to have 1.1, 2.2, 3.3, 4.4, 5.5. And if I sum them all together, I should get 16, I think. Because if we sum 1, 2, 3, 4, 5, that should be 15. But 0.5 and 0.4, 0.3, 0.2, 0.1. That should give me a value of 1.5. So 1.5 plus 15, I should get 16.5. And that'll be the value of sum here. And here we'll go about creating our own accumulate function here. And actually, I'm going to go here. I'm going to copy this. I'm going to comment it out. And then I'm going to put std accumulate, because that's the official function that's part of the standard template library. And then here I have my own vector of floats, in which I alternate between 1 and 2. If I take the mean of that, I should get 1.5 because, well, if I take the mean of just the first two values, that should give me a mean of 1.5. And if I just alternate between those two values, or I mean, as long as I have 3 1s and 3 2s, doesn't really matter what order they're in, I'll get a value of 1.5. More generally, if you have the same number of 1s as the same number of 2s, you'll get that same mean. But anyways, let's get started with our own accumulate function. So just like the other video where I covered min and max, this is going to be a generalized template function because, of course, accumulate's part of the standard template library. So I'll need to use a template to work this algorithm. So I'm going to be calling this an iterator, and I'm going to have a type name val. Right, so we're going to have two data types. The first data type is going to be an iterator, and the second data type is going to be some sort of value. So I'm going to return a value, and then I'm going to have ACC. I'm going to have an iter that points to the first iterator of a container, like a vector, and then I'm going to have an iter that's going to be the last. If I have first and last, I'm able to traverse the entire container that I want to iterate through. So if this was a vector, for example, I'd have a pointer to the very first iterable, meaning the very first element of the vector. And then here with last, I'd have a pointer to the last element of the vector plus 1. Finally, we're going to have a default value that we're going to start with, which is usually 0, but in this case, accumulate lets us have like some sort of offset parameter. So if you wanted to accumulate all of this, but you already started with another value, let's say 10, you can put 10 here as our result. When I call it here, I provided a value of 0. But continuing on with the algorithm, we're going to have a for loop and we're going to iterate through the entire container that we have, and with our begin point being first, and we're going to continue while our pointer is not pointing to the last. And I'm going to do a pre-increment of p. So why am I doing a pre-increment of p? Well, it turns out for these containers, these general containers, like lists and vectors and stuff like that, it turns out more often than not, these containers will have iterables that will have their pre-increment operator overloaded. So more often than not, this operator will be overloaded for these iterator types. So of course, with these generic algorithms, we want to be inclusive as possible. And since more often than not, these operators are overloaded rather than the post increment or the post decrement, I use the pre-increment. So again, in the for loop, I start at the beginning and I iterate until the last, and then I increment my little iterator as I go using the pre-increment, because more often than not, the pre-increment operator is overloaded for these iterator data types. So what am I going to be doing with this iterator data type? Well, I'm going to be summing it with res. And since these iterators are pointers, where first points to the beginning of our container, more specifically a vector in this case, and last points to the last element of our vector plus 1. Again, since these are pointers, I'm going to be dereferencing where I'm pointing to and summing that with the result. So we have an assumption here that the data type inside of the iterator where it points to is going to be the same type as val. So if I have a double here, which is going on here with val, and I have a vector of doubles, here I pass an iterator, two iterators, where the data type that they're pointing to is the same as val. So here we just iterate through the entire container, and we sum the contents of the container into res. Once all the contents are accumulated to res, we're going to return res. And that should be it for the sum. Now, I want to talk about my function mean. So what I'm going to do is I'm going to make it general. So I'm going to have a template, and we're going to have a type name. We're going to go with T just to kind of keep it simple. And I'm always going to be returning a double here. Well, yeah, I should always be returning a double, so I have precision with my mean. I wanted to return T, but sometimes if you take a mean of integers, sometimes that mean is not an integer. Moving forward, I'm going to call this mean function mean, and this is going to take an input of a vector of type T, and I'm going to get its v. I'm actually going to make this const, and then here what I'll do, I'm going to create double, and I'm going to say sum is equal to ACC v.front v.back, and then I'm going to give it an initialized value of 0. So I'm letting ACC do the hard work for me that's already done. So I don't need to go around and create another for loop to sum all the contents of my vector together. And simply what I'll return is sum divided by v.size. Now, should I do something if it turns out our vector has a size of 0? Yeah, we can do something like if v size is equal to 0. We're going to say, I think we can throw an error, say throw, I don't know, some division by 0. We can say std overflow division by 0. And that'll take care of it for us. And actually, since we're going to be including that overflow error, I need to include the library for throwing exceptions or throwing errors. And that library is called std except. So if it's 0, we throw an overflow error, which in terms of all the exceptions and error handling, this is the category that division by 0 falls into, an overflow error. And that makes sense because when you divide by 0, you essentially get infinity, and that's bad. And we can't represent infinity as a number with bits, right? The value is too high, it's too large, so the value will overflow because we don't have enough bits to represent infinity. So, I mean, with that kind of actually makes sense why it's an overflow error. But anyways, if the size is not 0, what we can do is we accumulate everything and then we just divide by the size of our vector, and we should be good. And I think with this, we're ready to test our homemade function. And after that, we'll do the same thing, but with std accumulate. Oops, it turns out I made out a typo. This is supposed to be sum. I put ACC. I can't print out a function. I instinctively went towards main. Pretty funny. But let's try compiling again. I understand my other error now. And this needs to be begin and this needs to be end. I don't know why I put front and back. So let's try it again. Okay, now it works. So my two errors that I got is that for some reason I put v front and v back, where I needed to put v begin and v end like I did with my accumulator here. And then the other problem that I had was that I was trying to print my accumulator function where I wanted to print the results of that function, which was sum. Now that this is compiled, and actually let's compile it again so that way we're sure. All right, we're good. Now that this is complete, we will try it now with using std accumulate. So I will uncomment this and comment this out. So let's see if we get any errors. Oh, actually, before I forget, rather than use ACC here, we're going to be using std accumulate. Hopefully you get the spelling correctly. Oh, and I just forgot the library that it's in, which is going to be in the numeric library. Numeric. And that should solve it. Yeah, so if we continue, we get the same result. So this is pretty good. So yeah, stood accumulate, pretty good function to use, part of the standard template library. It's a generic algorithm to accumulate the values of a container. You usually give a pointer to the beginning and the end, and a starting default value, which is typically 0, and it'll sum it up all for you. I hope this was informative, and here I have my own mean function that I typically use in my own personal programs when I usually need to take the mean of a vector, which happens a lot. But I hope this helps you start understanding the STL algorithms a bit more, and I hope that you can put this to use yourself in the future. Thanks for watching, and I'll see you in the next video.